Hey guys, welcome to Moop Math. Today we will be doing some more pre-calc questions. So the first question we have is factor this expression. We have 4x squared, it's not a very good x, minus 25. How can we factor this? So right away we can see that 4x squared is 2x squared. So we can say this is 2x squared minus 5 squared. Whenever you have a squared minus b squared, you can put it in this form. We have 2x plus 5 times 2x minus 5. So then we multiply this out, we get 2x times 2x, which is 4x squared. 2x times negative 5 plus 2x times 5, that's 0. Then 5 times negative 5 is negative 25, so there we go, it works out. So that's, I mentioned that in a previous video. This is a very common pattern. So this is just going backwards for this rule. We have a plus b times a minus b is equal to a squared minus b squared. That's a very common thing you'll see in math, and this is just going backwards. So we can also say a squared minus b squared can go to this. So in this case, you had to recognize these are both perfect squares and go back. It could even not be a perfect square, and you would just get a square root in here. Okay, moving on. Next question. Let's change to a lovely bright red. So we have 2x squared plus 5x minus 12. How can we factor this? Factor means put it into a nice form of a bunch of brackets multiplied together. Or it says this is an expanded form, and we want to go to a factored form. So if they ask you to factor, it means go from this expanded form to a bunch of brackets multiplied by each other, because it's a convenient way to show the zeros of the function, and the zeros are just when it crosses the x-axis in this case, but it can mean different things in different problems. So we have a polynomial. So when you have a polynomial, you're going to have, for the leading one, it's going to be 2x times something, and then x times something. And then here, so these two values are going to multiply to negative 12. So it'd be 2x times this and x times this. Add those together, it's going to be your 5x. So how can we do? Just got to do some mental trial and error. So negative 12 can equal like negative 2 times 6 equals negative 3 times 4. So let's just try the integer solutions first. If those fail, we'll use the quadratic equation. So 2x plus 2 times x minus 6. So 2x plus 2, we get 2x minus 6, we get minus 12x, so we get 10x, so that's too high. And this one, we get 2x plus 3 times x minus 4. We get 2x minus 4, which is negative 8x. And then we get 3x, so we end up with negative 5x. So that one, we have the right number, we just have the sign wrong. So it's actually 2x minus 2, x plus 3. So we do 2x times x, we get x squared. 2x times 3 is 6x, minus 2 is 4. Okay, that's not right. Maybe let's try 2x minus 3 times x plus 2, because it wouldn't matter in general, but I think because of the 2x now it's making it different. So we have 2x times x, we can change that. 2x times 2 is 4x. I thought we had it a second ago. 2x times 2 is 4x, minus 3 is just x. Oh yeah, it's 3 and 4, it's 3 and 4. That's my mistake. So I'm showing you the full process here, this is not scripted. 2x times 4 is 8x, minus 3 is 5x, negative 3 times 4 is negative 12. There we go. So now we expand it one more time to make sure. 2x times x is 2x squared. 2x times 4 is 8x. X times 3, negative 3 is negative 3x. Add those together, you get 5x. Negative 3 times 4 is negative 12. So there we go. There's our answer. That's how I would do it. And if all those, you can put these 4 numbers in every possible, you can do like negative, you can put negative 2 and 6 here, and then 6, negative 2 here, negative 3 and 4 here, 4, negative 3 here. You try all those combinations. I like to do it in my head, but if you can always do it on paper and work them out, or put your calculator. And if all the integer solutions don't work, and then you would use the quadratic equation, which is x1 and 2 is equal to negative b plus minus square root of b squared minus 4ac over 2a. And the plus minus will give you both values, and this here is called the discriminant. And the discriminant will determine whether you have 2 identical roots, 2 unique real roots, or complex conjugate roots. So that might be too advanced for what you're doing, but that's eventually where you would go with this. Okay, maybe outside the scope of this pre-calc point of view, but good thing to know. Okay, next question. We have x cubed minus 3x squared minus 4x plus 12. So what is this equal to? So right away I'm seeing that these two kind of look similar, because I can factor out the x squared from this one, or factor out an x from this one. I get x squared, sorry, factor out the x squared, you get x minus 3, and I factor out the negative 4 here, and I get x minus 3. Do you guys see how that works? I'm able to factor these two sets in such a way that I get an identical bracket. So this can now be turned into x squared minus 4 times x minus 3. And then my roots would be x is equal to 2 x is equal to -2 and x is equal to 3. So I'd say the answer would be this, and optionally you can also include this if the question was factor the following expression. So I don't know what that method's exactly called, but you kind of split it into two groups. You get a same bracket, and then you can just easily go here with no need to use any high-tech stuff like synthetic division or polynomial division, which are different techniques you use when you don't have an easy way to do it like this. So your teacher may provide questions that are easy to do. Either you can just do like that, and then they might provide ones where you have to use more advanced techniques. So here we go, next question. X to the 4 plus 27x. Okay, this one, you can factor this one very quickly. It's going to be x times x cubed plus 27. And you might say that looks fine to me, but can you further factor x cubed plus 27? These are both cubes. This is x cubed plus 3 cubed. Can you do anything with a cubed plus b cubed? This might be equal to, I don't know if that's a thing. Let me Google that quickly. I don't think it does. Yeah, I think that's actually as good as it gets. You can further factor it into this form. You can say it's equal to a plus b, and then a squared plus b squared minus 2ab because you get a cubed plus b cubed minus 2a squared b minus 2ab squared, and then you get ab squared plus ba squared. Let's work this out. A cubed plus ab squared minus 2a squared b plus a squared b plus b cubed minus 2ab squared. Is that actually right? I don't think that's right. minus just AB, sorry, minus AB. That is right, there we go. Okay, so you can factor into this. And then can you factor A squared? Anyways, I think this is fine. I think we leave it like this. So we say x is equal to 0 and 3. Triple root at 3. So 3, 3, 3. But really the roots are only 0 and 3. That's if this is equal to 0, though. If this is equal to 0, you get this. But if it's not equal to 0 and you're just factoring it, you can just get x cubed plus 27. I'd say factoring it, you just get to this form and you're done. Because they haven't given you any information about this function. Okay, moving on. This is the answer. Okay. Next question. We have 3x to the 3/2 minus 9x to the 1/2 plus 6x to the negative 1/2. What does that give us? Let's see. We can divide by 3. I'm going to divide by 3 x to the negative 1/2. And that's going to give us x squared minus 3x plus 2, which will give us x minus 1, x minus 2. And since we're dividing by the inverse square root, x is not equal to 0. So there's our, since we had to divide by this, by a power of x, we had to say x is not equal to 0. There we go. There's the answer. Okay, moving on. X cubed times y minus 4xy. What does that equal to? How can we factor this? Well, we're going to take the y out right away. We can take a yx out actually. We get yx times x squared minus 4. And we can factor this, our friend here, into yx x plus 2 x minus 2. And mentally checking this, x times x is x squared. These cancel out, and negative 2 times 2 is negative 4. So there you have it. There's your answer. You have two variables now, but you can still factor it just the same. Anyways, this has been Mould Math. Let me turn on a cool song. This has been Mould Math. I want to thank you for taking time to watch Mould Math. Actually, hope you enjoy Mould Math. If you enjoy the Mould Math show, please get in touch with me in the comment section and say, Mould Math, I desperately need private tutoring, and I will shoot you my email, and we can have a little powwow session where I mold your mind to be more mathematical, with the cool classical Strad music in the background being optional. Alright now, have a good day.